Hey guys, in this video we're going to be graphing rational functions. So for this we're going to rely on a lot of stuff that we actually learned prior to break, where we had to find vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, and holes. So we're going to identify those 5 things, and I'll give you a refresher on how to do those. And then we're going to plot those features on this graph, and it will graph our function for us. So let's start. Before you do any of these, I will give you a refresher on how to do each one. But what I want you to always do in these is to factor first. Always the best first step is to factor if you can. You won't always be able to factor, and what I mean by that is factor both the top and the bottom of the fraction. If there's 2 terms, you generally always want to think is probably going to be a greatest common factor. So on this top, it is GCF, and they both share an x, so we can pull out an x, and then we're left with an x plus 1. So that would be the factored form. On the bottom, do the same deal. It's 2 terms, so let's see if we can pull something out. They both do have a -5, so we can actually pull that -5 out. And then we're left with, be careful, it's not just x, it's x plus 1. Because if you were to do the opposite and like distribute into this thing, you would have to have that plus 1 in order to get the -5 there at the end. All right, so that is the factored form. Now what you've probably noticed is you get an x plus 1 on the top and the bottom. So what's going to happen is you're going to go ahead and cross that one out. That's going to make our next few things a little easier when we have to find the vertical asymptotes and the x-intercept in particular. It's going to make those a little bit easier. But one thing I want you to notice as well from the outset is this is a hole. So holes occur where there is a common factor. That cancels. So that's probably the easiest thing to identify first, where there's a hole. So that hole occurs at x plus 1, which in other words, if you solve both of these, you would get x equals -1 when you solve it. Right? So we have a hole at x equals -1. There's a hole there. So I'm going to go ahead and identify that. So a hole. Now, one thing that we do have to do is get the y-coordinate of that hole. So in order to get the y-coordinate, you're going to plug this in to the function, but you're going to plug it into this canceled form here. So you're just going to plug it into what's left over there. So the hole will be f of -1. We plug it into what's left of our function. So that's just going to be -1 over -5, which turns into just +1/5. So that's the y-coordinate. So we have our hole at -1, 1/5. That's the first thing. And it will get a lot easier from here, trust me. We got that hole identified, and then the rest is going to be pretty easy. So let's go ahead and click on hole, and then -1, 1/5. You're just going to drag this thing, and just do your best. I'm just going to put it right above -1 there. So approximately 1/5. Just do the best we can there. All right, so there's a hole in our graph right there. We got that done. Okay, now vertical asymptotes will be the next thing. Let's go ahead and do that. So for that one, we want zeros of the denominator. And as we said before, we said this little condition that are not also zeros of the numerator. So we said before, right? Now what we've done is we've already canceled out the ones that are common. So really all that's left over is just this part that I have circled here. And we have -5. So all we have is -5 equals 0, because this one canceled out with the top already, right? Well, that's nothing. That -5 can never equal 0. You have to have at least an x. So there's actually going to be none. Vertical asymptotes, there's going to be none in this case. But how you find them, again, is going to be zeros of the denominator. And if you've already canceled, then you don't have to worry about that if they're also zeros in the numerator. So there's going to be no vertical asymptote, so we don't need to apply anything for that. For the horizontal asymptotes, that is the zeros of the numerator. Zeros, oh, sorry. Take a step back. The horizontal asymptotes are not zeros of the numerator, sorry. Horizontal asymptotes, there's 3 rules for that, and hopefully you wrote these down. The first rule is we're going to look at, see if the bigger power is on top. If the bigger power is on top, that implies that there's no horizontal asymptote. The bigger power is on top, which is the case in this one because we got an x squared. So when we look at the original, we got an x squared on top and next to the first power on this one. So in this case, there is going to be none. But just to run through the other 2 rules, if the bigger power is on bottom, then there is a horizontal asymptote at y equals 0. Always be y equals 0. And third case, if the powers are the same, biggest powers are the same, biggest powers are equal. So let's say there's both an x squared on the top and the bottom. Then there's a horizontal asymptote at y equals the ratio of leading coefficients. There's a lot of information in all these. Each one is going to be a little bit different, but make sure if you don't have these rules written down that you're taking a picture or something of them. So that's how you find the horizontal asymptote. You look for one of these 3. And in our case, we said that in this problem, there's a bigger power on top. That means there's none. So we've actually determined there's none of the horizontal and none of the vertical. Interesting. All right, we already got our whole. That was at the -1, 1/5. The next 2 things we need are x-intercepts. So x-intercepts, that's where I was getting a little ahead of myself on the last one. X-intercepts occur at the zeros of the numerator, zeros of the top, that are not also zeros of denominator. And again, we've already canceled out the ones that are common where they are the same. So all we need to really look at is what's left, which is just this x. We just set that equal to 0. So we just got x equals 0. So we have an x-intercept at x equals 0. So what we do then, we click on that x-intercept, shows up here, and we're just going to move it to 0. And then what you're going to see is there's also going to be a y-intercept there as well because it's crossing at 0, 0. But we'll go ahead and talk about how you find that y-intercept. If you remember y-intercept, you simply just plug 0 in for all x's and solve. Probably the easiest one in most cases. Just plug 0 in for the x's. And what we want to do is actually plug it in the simplified version. So we can just plug it into that 0 over -5. So if I went back down here, sorry, 0 over -5, y equals 0 over -5, which is just 0. So y equals 0. We got a y-intercept, which we said was going to be the case because it crosses at the origin, so it's got to be 0, 0. All right, so we found our 5 things. Ended up not being any asymptotes, but that's okay. So we're going to go ahead and just hit the plot rational function. And it doesn't look amazing, but I guess that's what it's supposed to look like on this one. It actually kind of just looks like a linear equation. So let's go ahead and submit and see what we get here. All right, that's it. So I think in reality that should actually be curved a little bit. I'm not sure why it looks like that, but nonetheless. All right. Let's see if the other one turns out maybe a little bit different. All right. So as before, I know there's a lot going on in this. I'm just going to give you probably 5 of these. Do the best that you can on them. If you're really, really struggling and you can't get all the parts, just do your best to try, 5 or 10 and let me know that, hey, I couldn't solve them. And I can still give you credit for it. But I do want you to do your best to try to get all 5 right. But I know there's a lot of parts to these. So I can also see if you're attempting them. So if I see that you spent a long time trying them, I can even see how long you spent on each one that you missed. So don't email me and say, I tried 8 of them and I couldn't figure them out and you only spent 10 seconds on each one. So at least try them. Hopefully you can get 5 of these correct. If not, send me an email and say, hey, I tried my best and I couldn't get them and I tried a long time. So, all right, let's go ahead and try the next one. First thing, as I said before, is just factor. So this one is 3 terms. Whenever you see 3 terms, you're going to think factor into these 2 binomials like this. And we have to think what multiplies to give you the C and adds to give you the B. So on that top one, it's going to be x plus 2 and x plus 5. 5 times 2 is 10, 5 plus 2 is 7. On the bottom, a little bit more challenging because we got this 2 hanging out in front of here. Which means the first thing you would want to try to do is pull that 2 out if you could, if there was a 2 in all of these terms, but there's not. So unfortunately, we have to do that big X method that I showed you, or if there's another way that you've learned it, that's fine as well. But to do that big X, we do the A times the C on the top. So 2 times negative 10 is negative 20. And on the bottom, we write the B, which is just negative 1 there. So we think what 2 numbers multiply to give you negative 20 and add to give you negative 1. Well, that's going to be negative 5 and 4. Because negative 5 times 4 is negative 20, negative 5 plus 4 is negative 1. All right. So those are not our answers. It's not x minus 5 and x plus 4. We got to do a little bit more stuff. But the next thing that we do is we keep the first term, and then we're going to split this middle term into minus 5x and plus 4x. And then we still got minus 10. So we actually just sort of, we make the term a little bit bigger, but in doing so, we create 4 terms, and then we do factor by grouping. So we draw a line down the middle, and then we pull the GCF out of the left half, which is x, and then we're left with a 2x minus 5. And then we know that 2x minus 5 is going to match over here. And what we'd have to pull out of to get out of that would be a 2. 2 would be the GCF of the other half, so we're going to put a plus 2. So that if we were to distribute these in, you would end up with what we had before. We then pull the front 2 things together. So the x and the plus 2, x plus 2. And the back 2 are the same, 2x minus 5. And that becomes our answer. So we end up with x plus 2 and 2x minus 5. All right, and then now hopefully you'll see what's happening here. These 2 cancel out. So that tells us there is a hole there. Hole at, in this case, it's going to be x equals negative 2, right, when you solve it. So there is a hole there. Let's go ahead and put that hole on a graph. X equals negative 2. Oh, before we plot it, you can't just assume it's just going to be at, here's our hole here, negative 2, and then there's 0 on the y. We do need to get a y coordinate. So to get that hole then, we got to do f of negative 2. And when we plug it in, we can just plug it into this part here. That's what we want to plug it into. Otherwise, you're just going to get 0 over 0. So you only want to plug it into what's left over. So then we would have negative 2 plus 5 over 2 times negative 2 minus 5. So we get 3 over negative 9, which is negative 1/3. So our hole is at negative 2 comma negative 1/3. All right, let's move that. Again, I know this is difficult, so just do the best that you can. Negative 2, negative 1/3. All right, that looks good. So let's go on and go to the next one. Hopefully they get a little easier. Next up, let's do vertical asymptote. For a vertical asymptote, that's when we zeros of the denominator. We already have it factored, so it's just going to be what's left over here. So it's just 2x minus 5 equals 0. 2x equals 5, and x equals 5 halves. Because the other one canceled out. So we're going to click on vertical asymptote. 5 halves would be between 2 and 3. So that would be 2.5. So just as close as you can in the middle there. I don't think you have to be exact, but it looks pretty good. 5 halves. For the next one, horizontal asymptote, that's where we're going to be looking at the powers. So we've got an x squared on top and the bottom. So we do the ratio of the leading coefficients. So that's going to be y equals, there's an invisible 1 in front there, so 1 over 2. 1/2. Horizontal asymptote, y equals 1/2. Okay, next one, x-intercept. That's when we want the zeros of the numerator that are not zeros of the denominator. But we already have it factored, so it's just whatever's left over up there. X plus 5 equals 0, so it's x equals -5. So we click on x-intercept. It's right here. X equals -5 there. And last but not least, the y-intercept. Plug in 0 for all the x's. So f of 0 equals, we're going to have 0 squared plus 7 times 0 plus 10 over 2 times 0 squared minus 0 minus 10. And you'll see is that you get 10 over -10, which is -1. You can also just plug it into the simplified version too. In that case, you would just get 0 plus 5 over 0 minus 5. So you would get 5 over -5, which is -1 as well. So y equals -1. That is our solution. So we'll click on y-intercept and go down to y equals -1. Drop it there. All right, and then we already got our whole. So we just put all of these on, and then we hit plot rational function. And boom, that looks a little better. That's what we're used to seeing. So there we've done it. That is our rational function. Let's go ahead and submit, see how we did. All right, we got it right. Good deal. Okay. Again, just to emphasize, I know these are challenging, so do your best to get 5 of them right. But if that's becoming a problem, reach out to me and let me know. All right, just go step by step. Always the first step is to factor it. So on the top, we have 2 terms, which you should be thinking GCF. And it looks like we want to pull out, I always try to pull out, if there's a negative attached to the x, pull out that negative. So -2 times x, and then it will become -2. And then you can always check by distributed in. -2 times x is -2x. -2 times -2 is +4. So we're good. Now the bottom is 2 terms, so you would think GCF. However, this is just one exception. Notice how they're both they're both perfect squares. It's called a difference of squares. So we got x squared minus 4. So this is actually going to become x plus 2 and x minus 2. You can think of there sort of as being like a 0x in the middle, but this is called a difference of squares. It's kind of a special case. Hopefully you can remember some of that factoring stuff from last year. It's x plus 2 and x minus 2. Because when you FOIL this, first term gives you x squared, outer gives you minus 2x, inner gives you plus 2x, and those cancel. And then last term would be minus 4. All right. Let me delete that there. Okay, so let's go ahead and cancel what we can. And that'll give us our whole. As you can see, x minus 2's cancel. So there's a whole there. And that would be at x equals 2. And then remember, we got to plug this into what's left over here. So for a whole, we do f of 2, but we're going to plug it into just what's left over. So we get -2 over 2 plus 2. So -2 over 4, which is -1/2. So we get 2 comma -1/2. Is our whole. Let's go ahead and put that on. So 2, the x, -1/2, the y about right there. All right, next up, vertical asymptotes. So that's the 0 of the denominator. that are not also zeros of the numerators. Since we already canceled out that, all we're left with is the x plus 2. So that equals negative 2. It's vertical asymptote. X equals negative 2. Drag it over. Boom. Let's try horizontal asymptotes. So for that one, remember we're looking at the powers. We had a first power on the top and a second power on the bottom. If it's a bigger on bottom, that means it's always at y equals 0. So let's go ahead and plot that. Boom. All right, next up is x-intercept. X-intercept is zeros of the numerator that are not also zeros of the denominator. After we canceled, all we're left with was negative 2. So negative 2 equals 0. Well, there's no x term there, so that's just none. No x-intercepts. And last but not least would be y-intercept. That's where we plug in 0 for the x, and then see what we're left with. And if we do f of 0, it's best to plug it into this one. We get negative 2 over 0 plus 2. So we get negative 2 over 2, which is negative 1. So we got a y-intercept at negative 1. There. All right, let's go ahead and plot it then. Make sure you hit that plot. Oh, what did I say? Oh, I think I accidentally hit x-intercept in that one. Sorry, when you get rid of the x-intercept, there was none. It just told me I couldn't have an x-intercept where I had my asymptote. I think I accidentally pushed that instead of the y initially. So we double checked. We got vertical asymptote at negative 2, horizontal at y equals 0, x-intercept none, y-intercept at negative 1, and our whole was at 2 negative a half. Let's try it out. All right, that looks pretty good. Let's go ahead and submit. All right. Let's go ahead and let's maybe try to do one more. See if we can find a different scenario. Let's do this one. All right. Last one here. This one looks a little bit challenging, but we'll go ahead and go for it. So on this last one, first thing we always do is factor. Now the good thing is, well, bad thing first is there's a number in front of there, which means it's going to be harder to factor. However, 3 does go into 21 and it does go into 36. So that's good because we could actually pull that out first. So pull out the negative 3. And then you're left with x squared. This will be minus 7x and then plus 12. So when you pull out the negative 3, you just you can check by distributing it back in. That will give you negative 3x squared plus 21x minus 36. And then we'll just factor what's left over here, this trinomial. So negative 3, and then we'll have 2 sets of parentheses. I think what multiplies to give us 12 and adds to give us negative 7. That would be x minus 3 and x minus 4. On the bottom, we've got 2 terms, so we can think GCF. GCF there is just 5, so 5 times x minus 4. Let's keep this here, 5 times x minus 4. And you will see that we get a cancellation. Boom, boom, that's our whole there. So that's x equals 4. And then remember, we need to plug it into what was left over there. So f of 4 will be negative 3 times 4 minus 3 over 5. So we get negative 3 times 1 over 5, which is negative 3/5. So our whole is at 4 comma negative 3/5. Let's go ahead and put that. Whole 4 negative 3/5. That's going to be a little hard to graph, but just kind of put it close to negative 1, and that should be adequate. Okay, next up is vertical asymptote. After you get these factored and find the holes, the rest isn't really that difficult, but it's just getting it factored first, I think, and finding that hole. And then the vertical asymptote is just going to be zeros of the denominator that are left over. However, all we got is 5 left on the bottom, so it's just 5 equals 0, which means none. For the horizontal asymptote, that's where we'll look at the powers. We got a bigger power on top than the bottom because we had a second on the top and one on the bottom, which means there's none. We then want to look at x-intercepts, so that's going to be zeros at the top that are left over. We got -3 times x minus 3 left. That -3 just disappears because you just divide by -3. So we got x minus 3 is 0. So x equals 3. That is our x-intercept. So drag this to 3. And then last but not least, y-intercept. For that, we're going to replace all of the x's with 0 in the simplified form there. Y equals -3 times 0 minus 3 over 5. And we get -3 times -3 over 5, which would be 9/5. 9/5. All right, which if you want to make that a decimal and make it easier on you, it's going to be 1.8. 1 4/5. All right, so let's go ahead and give that a shot. Plot that one, and that should be it. 1.8. Right under 2. Let's go ahead and plot it, see if it works. I don't really like this one much either. I don't feel like it should be curved a little bit, but at any rate, that's what it looks like. And we did it. Okay, good luck on this. Again, try your best. Forget the rest, and let me know if you have questions.